Good afternoon, ladies and gentlemen. What I'm going to talk about this afternoon is, as it says up there, the demolition of a high-rise tower block by the controlled use of explosives. The reason I've chose this subject is because we still get telephone calls from companies. I know you know, some of you know a lot about it, but you get companies saying we didn't use explosives because we couldn't evacuate a kilometre zone around the building, or people ringing up and saying we've got this building we want to implode the week after next. So hopefully by going through the sequence of a typical explosives demolition, you can pass the word of the type of time it would take and the type of systems we would use to do the project. The project I'm going to go through is the way I did it with a friend of mine on a tower block. Obviously, William at SafeDem, John at Precision, Fabio will do it differently, but basically they'd all use similar types of procedures. The first time I spoke here a couple of years ago, I spoke about South Africa, which was a great location. Last year I spoke about the Middle East. I'm afraid we've gone a bit downhill, and this time I'm going to talk about Chantrey Tower Block in Sheffield. It doesn't get less sexy than Sheffield, trust me. The reason I'm using this as an example, it's one we did earlier in the year, and it's because of the close proximity of a building to the rear of the structure. That's a Google site plan. The building at the top, of the screen was being built. That was completed when we actually did the project. And you can see the blue area are the buildings in close proximity, and the red is actually the building that we're going to demolish. The one at the top is basically an old people's residential centre where there's about 70 residents, all in old age. And the one to the left of it is a sort of a recuperation building for old people that have come out of hospital that need care for a couple of weeks before they go home. Here you can see the building. They had roads on three sides, three elevations, but the main problem was the new build at the rear. It was only 6 metres from the back of the building to the new build, the old people's home, to the rear, and there were services that ran in the path. And there you can see a close-up of it again, showing how close the new build was to the structure. The building construction, it was basically concrete, in situ concrete, with no fines infill. No fines is cement and aggregate with no sanding. It's more of a cosmetic than a construction material, but it was used infill in the building. And there were a number of columns throughout the building, as you see when we come on to the drawings a bit later. The project team, the client was Sheffield City Council, and they had their own contract administrators and CDM coordinators, again from Sheffield City Council. They were overseeing the project. The main demolition contractor was Demex, again a Sheffield-based company, and the explosive specialist contractors was Index, myself, and SES, Specialist Explosive Services. At this stage, I'd just like to mention SES, their lead explosive engineer was a good friend and colleague of mine, Philip Lowe, who was well known throughout the blasting industry, and a lot of people within the blasting industry owe a lot to him and his father for the way they pioneered it. The reason I mention it is because at the beginning of the project, when it came into the design, Phil was available. Unfortunately, during the project, he passed away, so he wasn't around to see the end of the project. But he put a lot into the project, and he'll be sadly missed. The criteria for a demolition, whether it's explosives or any type of demolition, is very similar. The main thing is nobody gets hurt. Secondly, that the building comes down. Thirdly, there's no damage to the surrounding area. Fourthly, some may put this higher up the scale, but the project makes money. The project's completed on time. And finally, that the client's left happy, so you get repeat business. You leave a nice taste in his mouth, so he gets you employed again. Prior to starting any work, we had to provide certain information to the client to give him confidence in what we were going to do, and that involved detailed methods of work, which included the collapse mechanism we were going to use, the types of explosives we were going to use, the initiation system, the protection we were going to use to make sure nothing got damaged, the area of the exclusion zone that's going to be around the building, and any contingency plans that would be needed in the event that things didn't go right. And all this was checked prior by an independent auditor, which in our case it was Waterman Structural Engineers. They checked everything to make sure everything was right. And they actually have an engineer who knows about explosives as well, so he could check the explosive side of it. The method of collapse, we're very lucky now because with the development of delayed detonators, we can do what we want with the buildings. Here you can see where we're demolishing a building from one side. In that case, in the centre, there was a building we had to protect, so we started the building from one side towards the other. Here, because there's obstructions on the left and the right, we can collapse it from the middle. Here, because it was on top of the hill and we didn't want it to roll down the hill, we did the sides first and then the middle. And here we did front to back because there was a school in close proximity behind. What I'm saying is by using delayed detonators, we can, providing there's some room around the building, get the rubble pile to go where we want it to go. I noticed this morning with Despa and Cardem and last presentation with Fabio that 3D modelling is coming into its own. And I felt that we in the UK shouldn't be left behind and we should incorporate the 3D modelling into our presentations and our projects. I was very lucky that we had the old people's home right next door because I managed to get the old ladies to actually bake us a nice cake. Unfortunately, due to the strength of the marzipan and the amount, the height of it, we could only get 10 stories. And it did start collapsing on us, but there's the people that made it. Okay, I've got to say it didn't cost £20,000, but we put something in their charity fund. It was obvious from looking at the close proximity of the buildings, the design was going to collapse it away from the building at the back, which was called White Willows. So that's the way we designed for the collapse. The way we did that, you can see the arrow showing the direction of bias. We basically incorporated delays throughout the building, starting at 0.3 of a second, working to 1.5 seconds. So we put it into 4 sections, so it would fall away from the White Willows. And there you can see it again. What we also did was on the ground floor, we drilled 1 hole in the rear columns just to crack it, 2 holes in the next row of columns, and then everything else had 3 holes. So again, you were forming a little wedge so it would tip forward. We did the same higher up, but we incorporated a small delay between the bottom and the upper floors, so again it would give it that little bit more tilt. Probably overkill, but we wanted to make sure it tipped away from the building behind. Again, you can see we've gone from 0.5 of a second to 1.75 seconds. We had 5 main blast floors, and a little bit of the second floor we did what we call a secondary floor, and you can see at the top there, that was the idea, that it would tip over and pull away from the building to the rear. There you can see that represents the blast floors. The sequence of operations, phase 1, set up the site, soft strip and asbestos removal. This was done by the main contractor prior to us arriving, but I've got to say the soft strip, the removal of materials, was the best I've seen. You can see before the event, when they'd cleared it out, they'd taken everything away, so all that was left in there was the bare concrete and a little bit of steel work, and it made our life easier preparing the building, and it also made it better to recycle the materials after. So it was a good clean building. The sequence of operations from when we arrive on site, the first thing was to pre-weaken. I'll go through these in more detail in a moment. To drill the building, to protect the building, to charge the building, the blowdown of the building, the clean-up operation, and the removal of the rubbish. If we start with the pre-weakening, there you can see a floor plan. The walls in the middle are in situ concrete. What we had to do, we had to break holes in those walls so that we could drill all the walls. All the walls within the structure need to be drilled in this case. So what we did, we employed machines and men to break out openings so that we were left stood on columns. Thank you. We also did a cut around the front of the building, so when it collapsed on the ground floors, on the lower floors, the actual columns would shear in the front. Here you can see the guys working. We used jackhammers on some of it, and we also used machines on some of it. A lot of it was quite thin walls and no fines, which was easier to do with jackhammers rather than using the machines. And there you can see, that's something what it looked like. A nice clean job. This is the reason I'm using this for the presentation. Sometimes you have to climb over rubble because you haven't got the time or the skill. This was a nice clean job. And you can see the building pre-weakened. The lines, the red lines, represent the drilling, which we do afterwards. Again, that's the ground floor. Obviously, a structural engineer has to confirm that all this can be taken out and the building won't collapse. So we have a structural engineer that we employ to do the necessary calculations. We always carry out a test blast. No matter how many times we do a building or a building that's similar, we carry out a test blast. And the aim of the test blast is to confirm that the charge we're using is correct and the protection details or the protection that we use will stop any fly. We select the walls that are representative of the walls throughout the building. We then wrap them, protect them with the material that we're going to use on the finished product. We may vary, we might do one protection on one wall, a different protection on another, so that we get a feel for different types of protection. We then charge the wall, putting in the explosives that we're going to use or hope to use for the project. That would go right inside the hole. I'm just showing that to represent the explosives, which again I'll talk about in a moment. And then we fire the demolition. Before we do that, we have to erect witness boards. There's a thing now in the UK that nothing is allowed to go further than 3 meters from the wall. So when you fire explosives on the wall, nothing goes further than 3 meters. It's been many years now since they've had that rule. Before, 20 years ago, it used to cost us €300 to protect a floor. Now it costs us 3,000 because they don't want anything coming out the walls. Before we used to just put tin sheets over the windows to stop anything going out. Now we have to wrap every individual wall. So we erect the boards that we paint, and we also draw a grid on the square, and that's so when we fire the test blast, we can record if anything's got out, if there's anything on the floor, how far it's gone. And then we fire the test blast. Here you can see that's actually been fired. You can see a slight rippling in the protection. That's because when you've taken it off, inside you can see the wall's been disrupted. Nothing's come out, nothing's flown, and also the wall's been disrupted enough for the load-bearing capacity to be taken away. We did 2 test blasts. That's the second one. Again, we used a different protection method, a different charge weight, but again, nothing came out. And when we removed the outer protection, it disrupted the wall. And we always do a test blast on every project, as long as it's structurally safe to do so. We then went on to the drilling. There was about 800 holes to drill, which is relatively not a lot in this day and age. It's not unusual to maybe do 2,000 holes in a tower block. We only had 800 to drill here. We've tried using machines with drills on, but it's difficult. They don't keep straight. They look good on the videos, but actually when you try it, you hit rebar, you pop out. If you've got a guy there, he can control the drill better. Use air legs where possible, or just hand drilling. As you see, there's various rules now in the UK about drilling and vibration, so we have to rotate the drillers, we have to have anti-vibration drills, we have to have special gloves, we have to keep log sheets of everybody drilling so that they don't over drill and cause vibration problems. Basically, we drill every wall. That's just representation, but we drill every wall within a blast floor so that when we fire it, all the walls will be taken out. Sometimes we hit the outside walls on the lower levels so that the building will topple, but generally higher up, where possible, we just hit the internal walls. Once we've drilled it, we put the protection around. I showed you on the test blast the protection. Basically, we wrap all the walls up, chain link, geotextile, either both, one or the other, depending on how the test blast went. There was columns, so again, we have to put a bit more protection there because we're using a bigger charge weight. And once we've done that, we also cover the windows either from the inside or the outside. We know for a fact that nothing will get out of the protection from the test blast, but just in case it does, we also cover all the windows and all the openings around the blast floors. And here you can see this is basically the finished product. The building's protected. It also helps on security around the bottom. It means there's just the one doorway for people to get in and out. The nearby structures, we have to protect any services, which we do by putting the spoil on top or rubble and road plates. The building to the back, as you can see there, what we've done, we've put the black material, the terram over, just to any small stones to stop them hitting the gable end and the windows, and we've put the containers down to stop the rubble running back into the building. Behind the containers there's straw bales, which are like a cushion, and we've also tied strops from the containers into the building, so the weight of the building on the strop will help prevent it pushing back into the building. Charging up, when we come to putting the explosives in, There was 5 main blast floors, as I said. A secondary floor. We used 800 individual charges, so every hole we drilled had an individual charge with an individual detonator on. Approximately 30 kilograms of explosives spread over the 800 individual charges. 2.5 kilometers of detonating cord. Detonating cord was the main explosives, the primary explosives we used on the project, which I'll show in a moment. This is the detonators. There's various detonators that you can use, electrical, non-electrical, electronic now. This is the delay detonators, the LP detonators we used. They come in a series of delays going from 100 milliseconds, which is 0.1 of a second, up to 600 milliseconds, which is 6 seconds. There are various other ranges as well. This is just an example. And basically the delay is in the detonator. So the detonator that's attached to the detonating cord goes in the hole, and that's where the delay is. So if you have any cut-offs, if you've got any tubes cut, it doesn't matter because the detonator's already activated. This is detonating cord. That's the only explosives we use within the block. We don't use sticks of dynamite, gelignite, Semtex, C4, whatever you want to call it. It's all that. That looks like a bit of coax out the back of a television, but obviously it's got explosives powder inside. A couple of examples there. The red at the top is a 100-gram detonating cord, which means there's 100 grams of explosives in 1 kilometre in length. The bottom one is 10-gram cord, which is 10 grams of explosives in a metre length. And obviously you use the type amount of explosives that you want to do. It's good because it comes in rolls, and you can just feed it down the holes. There's no actual colour coding. You might go to one country or one company and find that the red is 10 gram. You might go to another company and find it's 30 gram, 40 gram, 100 gram. So they've got no actual colour coding. It just seems to be whatever the manufacturer seems to have spare in plastic. That's the detonator connected to the det cord, and that's then pushed down the holes. These holes that we drill are generally about 1.2 to 1.5 meters deep. So that would be pushed down through the center of the wall and tucked in. The detonator's right down the bottom of the hole. Some people put the detonator at the top. Again, it's not wrong, it's just different. Different people use different techniques, and whatever people are comfortable with. And then you connect all the detonators together so that you can fire it from one firing device. The method we used on this was 6-gram detonating cord, which is the pink stuff. There you can see it. We had detonating cord, and then we clipped all the detonators to that cord. It's one method, and the Americans use this method quite a lot. We generally used to use the system that comes with the non-L, which is connectors, bunch connectors, things like that. But as long as you've got a method that you're comfortable with and that goes to one point where you can fire the demolition, different people use different methods. The exclusion zone, basically around the site you need an exclusion zone. For this project, you can see here, it was about 120 meters. So it's not very big. We probably could have come into 100 meters. You can see there the green area is where we expect the debris to spread. The red area is the building, and the red lined area is the exclusion zone. We evacuate that area. Now there were people, because I said there was very old people in the area that couldn't be moved out their properties. So it's quite feasible to let them stay in as long as we know they can't come out their properties when we push the button. We know from doing our tests that nothing's going to come out, so nobody's going to get hit with flying concrete. But what the danger is, if you had people in the area, would be that somebody came out of their property and walked into an area where the building was being demolished. So for security reasons, for safety reasons, and because the HSE and the police have all agreed, we have to have an area of exclusion, which, as I said, is about 120 metres, and that's not unreal for many projects up to 22 stories. That's the sort of exclusion zone you might have. The idea that you have to have a kilometre or half a kilometre around it, not this day and age, unless you're not using protection. Security personnel, the guys around the zone have to be suitable. That means they have to be, if they're in England, they have to be English speaking. If they're in India, they have to be Indian speaking. So they have to speak the language of the country they're in. They have to be mobile, and they have to have common sense. The thing is, in the UK, with security, you get what you pay for. So if you go for a cheap security firm, you're going to end up with clowns. Okay, so you have to make sure the security guys are of the right ilk. They get vetted and police checked, the company that they've used. They get fully briefed on the day by the explosive engineer on site. and there must be a sufficient amount for the task, so that if someone wants to go to powder their nose or whatever, there's somebody can stand in for them. And they must have communications to the control point and backup. We're very lucky because we also have a police involvement to ensure the professional standards and security is maintained. And as you know, the UK, we've got the best police force in the world. Okay. The actual blowdown then. The building's been prepared, the area's been evacuated, we come to the blowdown. I'll do the slides first and you can see a bit of video. So remember where the blast floors were? There was 5 blast floors. Theoretically, if you're doing the job right, nothing should come out of the building. You shouldn't get any stones coming out. The building should just come down. There you can see the first detonation. That's dust coming out the window. That's just dust from coming through the holes in the geotextile. And there you see the delays at the front and the way the building's falling down, pulling away from the rear. The back, the blue is the containers next to the white willows. Still pulling away. Just to prove that I didn't do that with Photoshop, we've got some video of the demolition, which we'll just show now. There you can see the containers. Sorry about the quality, but it was a very rainy day. The good thing about the bad weather is it gets rid of the dust very quick. This is in slow motion. Very slow motion. You can see how the front starts. It starts to move and it pulls over the building away. And basically what you're left with is a rubble pile. As you can see, the main pile is away from the white willows. The containers have stopped anything running back into it. We have a clean-up operation, which basically then a team goes around, cleans around the area and makes sure that the residents can come back into a safe area. Then the rubble removal, 7,000 tonne, that has to be taken away off site. And you finish up. That's the job now. We did this in April. That's the site now, having been cleared away, regrassed, ready for redevelopment when they decide what they're going to do. I know we're running late and it's been a bit rushed, but any questions? Thanks, Nick.